Inside your computer, there's a tiny chip that thinks faster than you can blink. It's called the CPU, or Central Processing Unit. It's smaller than your fingernail, but it can perform billions of operations every second. But have you ever thought, how does it actually work? How does electricity turn into calculations, videos, or the words you're seeing on your screen right now? Let's break it down, step by step, in the simplest way possible. Think of the CPU as the brain of your computer. Just like your brain receives signals from your eyes, ears, and body and sends decisions back, the CPU receives data from memory and storage, processes it, and sends results to your screen, speakers, or printer. When you open a program, say, a calculator, your computer loads the calculator's code into memory. Then the CPU reads those instructions, one by one, and performs the mathematical operations you ask for. Inside the CPU are billions of tiny electronic switches called transistors. Each transistor can either allow electricity to pass or block it, just like a light switch that can be on or off. These on and off states represent binary, 1 and 0, the language of computers. When millions of these tiny transistors work together, they form logic gates, small circuits that perform basic operations like AND, OR, and NOT. When you combine billions of logic gates, they can do complex math, compare numbers, make decisions, and run full programs. Now, here's where the magic happens. Electricity flows through the CPU's transistors at incredible speed. Each transistor reacts to that current, either conducting it, 1, or blocking it, 0. By controlling how current flows through billions of these gates, the CPU can represent and manipulate digital information. This is where software meets hardware. Your code, written in languages like Python or C, is just human-readable text. When you run it, the compiler converts it into machine code, which is a long series of ones and zeros. Those ones and zeros are the exact signals the CPU understands. Every CPU in the world follows the same basic cycle, called the fetch-decode-execute cycle. 1. Fetch. The CPU fetches an instruction from memory. For example, add these two numbers. 2. Decode. It then decodes the instruction to understand what to do. 3. Execute. Finally, it performs the action, using its internal circuits, registers, and ALU, arithmetic logic unit. The ALU is the part of the CPU that actually performs math, adding, subtracting, comparing numbers, or checking logic conditions. After executing, the result is sent back to memory or an output device, like showing the number on your calculator screen. Now think about it this way. The CPU doesn't actually understand numbers or words like we do. It's just moving electrons. The electric energy that flows through the CPU is controlled in such a precise pattern that it represents logic and data. So yes, when your computer calculates, streams a video, or plays a game, it's actually just electricity switching billions of transistors on and off in perfect synchronization. You can think of it like a city full of lights, where each light turning on or off represents a bit of data. And the CPU is the conductor, making sure every light changes at exactly the right time. Modern CPUs have multiple cores, meaning several processing units inside one chip. So, while one core might handle your video player, another might handle web browsing, and another your antivirus. They all share the same memory and work together. That's why your system feels fast and responsive. Inside each core, there are billions of transistors connected through nanometer-scale circuits, smaller than the width of a human hair, all powered by electricity and cooled carefully to prevent overheating. So, in simple words, when you click a button, it sends an electrical signal. That signal reaches the CPU, where transistors open and close to represent logic. The CPU performs mathematical calculations using those logic gates and sends the results back as electrical signals again, which your monitor converts into pixels, your speaker into sound, and your printer into ink on paper. Every single app, game, or website you use is just electricity, flowing through silicon, following logical patterns, and turning into information, visuals, and sound. Let's sum it up with a simple example. Imagine a chef in a kitchen again. The recipe is your software code, the ingredients are your data, the chef is your CPU, and the electricity is the energy that makes the chef move. Together, they cook up the digital world you see on your screen. So next time you press a key or play a video, remember, behind that action are billions of tiny transistors flipping faster than lightning, turning raw electricity into logic, logic into code, and code into life. Thanks for watching. If you found this simple explanation helpful, don't forget to like, share, and subscribe.